So before I get into the full-on content, I want to make a point. You know, there are a lot of people in this space, you know, the big heavy iron makers, whether it's an Alcatel-Lucent or an Ericsson or the Chinese guys that are making this stuff for the carrier space. They're doing it for the mobile operators, but that doesn't mean that they're not happy opportunistically to make money off you guys if they can, which is great. We all have to deal with competition, right? You certainly do in your markets. But the stake I'd like to drive into the ground is that of all those people, we're the only ones who can look at you in the eyes and say, you are our primary customer set. And because of that, we're doing everything that we can possibly do. In fact, my boss is over in Israel trying to make adaptations and how some things get even priced on the LTE with respect to NMS and things like that. And in support of North America, things that we can do to, frankly, what we can call more wispatize LTE for the market. So here are some of the things that we're doing specifically. You may not know it, but Layer 2, coming at it from mobility first, doesn't have mechanisms in it for Layer 2 and Layer 3. Static IP, that sort of thing. So we have done that, and we are doing that as part of the core. So that's one obvious bit that shows it to the fixed space. And we're doing it even without violating the standards. It's basically like taking the standard and putting a roof rack on the vehicle, right? So it's kind of a plus feature without breaking standards compliance. Second, we know the WISP community, the fixed wireless community, likes to use radius. Well, LTE doesn't use radius. It uses the diameter protocol, which is more expensive, more complex. So early on in development of this, we partnered with a company called Radial to try to get a radius implementation over AAA. We've done that, and the work has been done. However, that's not far enough as far as we're concerned, so we're working with the free radius community to help them develop a solution for LTE, because guess what? They haven't done that yet. They've got it for WiMAX, and they've got it for, you know, the Wi-Fi side of the world. And Nick has even crafted some documents with the information they need so they can take that and do all the work that they have to do, the coding to do that. Nick, do you have any comment on that specifically, kind of what you've done there?
Only specifically that I've worked with our R&D to outline an interoperability spec for the open source community, and not only specifically free radius, but other radius vendors that want to engage and adapt an LTE module within their radius application. Certainly we'll be happy to cooperate in that regard.
So we're donating our time to, you know, to any serious organization that's interested in helping create open source, you know, feature sets. So to that end, we're working with the guys at Wismon. As I understand it, they've been pretty good trying to get hold of the coders at PowerCode with the help of some new customers. We're working with, started working with Jim Patient at towercoverage.com to enable low-cost radio network planning, which, you know, I know a lot of you guys like to use his stuff. And we're doing things to, you know, to try to make modular EPC functionality that's specific to the fixed space. So that said, I'm just going to leave that one hanging out there. It's just what I want to just try to let you guys know. We're doing what we can to productize this for the WISP space. So here's the network that is the basis of the bill of materials stuff I'll show you. So looking at you know, the diagram, this is the whole thing. This is all the stuff, and all the pieces are actually embedded in this thing. By the way, this is recording, and I'm going to try to get it up there. And also, some of this I can probably email to folks later on. But really, you've got three sides. You've got the complete back end. You've got the telcore side, and you've got the radio access network side. Okay? I just want you to have this view in mind as we kind of move on from here. And we'll go back to this and into some level of detail, especially as we explain certain aspects of these guys. So let's start with the radio access network side. And I'm going to pull pieces of the bill of materials that comes right out of when I'm doing sample quotes and that. So on the base station, or an LTE speak, what they call an E-Node B, these from a 365 arrangement are the pieces and parts right here. Now, in 2.5, were you to do that, the only thing that really changes is the base station itself and the antenna. But just looking at this, the core pieces, physical part of the base station are right in here, and even this guy is optional. This piece is optional. So you're at the base station, an antenna, a GPS, and the LTE license. It's just the LTE license. People ask, why is there an LTE license? Because there are royalty requirements both to, strange enough, the Israeli government, which has, like the Canadian government, does some support of internal R&D companies doing an R&D within their borders to help them develop things. But there's a requirement on the back end that some royalties are provided. So that's what that comes from, as well as, LTE has a lot of IP, a lot of intellectual property to a lot of different people. And that's really the nut and where that thing goes. But in any event, you've got your base station, antenna, mounting kit, GPS. Here's a couple optional items that you might use. Now, what do these things look like? And then as you scale, you might go here. Well, let's go drill into this a little bit. Base station. I'm really going to get remedial in some sense. Pretty simple. This is the part number, the US part number. This is what it includes. It includes a basic pole mounting kit. It includes the gland wrench, and includes this roughly 17-pound little monster, which is less than about 23 centimeters tall or so. And the bands it supports out of the box in the first carrier, it supports both bands 42 and 43, certified by the FCC and Industry Canada for both those bands. LTE calls them bands 42 and 43. How you and I know them more commonly as would be 365, which is actually 365 to 3.7, which actually crosses in here, but includes also this guy here for the future band, right? The future 355 band. So it's actually a dual band in that sense, covering two ranges of frequencies. And then there are two individual carriers. This is the per port power relative to what many of you are more commonly used to. With the two most common brands, I believe, are 22 dBm per port, which aggregates in 2x2 to 25 dBm. When you're doing 4x4 with our stuff, using all 4 ports out of the antenna, you're pushing out 36 dBm. So, and invariably, you have to power down to get to stay within FCC max. And most of your competitive stuff, you really need a high power antenna just to get to the max. What does it look like more specifically? Many of you know this, but just so you see, it comes with the mounting gear, and these are the mounting ports, very simple mounting. You can see the various interfaces. This, by the way, this 10100 port is also a port that allows for out-of-band management. So not only is it, can you direct connect to drill into the base station, there's also a bridge externally, so you can connect, a camera or something like that, or a direct connect to backhaul or something to that. And then, of course, you've got an SFP, and you've got 10,000 base T. So further, the other parts that I showed in that first slide So this antenna right here, this is this antenna. Okay, so this is a dual slant, dual pole, 65-degree, 4-port antenna. Now, we've had many conversations with a lot of you, and you say, why do you use a 65-degree antenna when you're doing 360? Well, the goal is to maximize the power density. This is a really, really good, high-quality antenna that rolls off about 3 dB on the edges, and this is what its pattern looks like. So when you've got 3 of these, you actually get very nice 360 coverage with very little gap and maximized power density. That's how we designed it. In fact, Nick will often, for the guys up north, kind of the standard configuration is actually 4 of these. And there you could do reuse of 2 front to back. So the GPS, so you can see kind of how that works. That can be daisy chained on the tower. And typically at this point we recommend it. That's a relatively new feature. It didn't used to be able to do that, but you can. So unless you're really gaga off the concept of redundancy, where you can do a GPS per, a general recommendation would be to daisy chain on a given tower. So that's what those things are. And then the mounting bracket for the GPS is this guy over here. I have this thing so you can literally see the pieces and understand the whole bit. Again, Nick, if you see questions popping in, please let me.
Yeah, keep an eye, Patrick. We're good so far.
Okay. So on the subscriber side, in LTE speak, it's called a UE, user equipment. That phone in your pocket, that is a UE. Okay? So that interface from the red box outside your convenience store that speaks up to Verizon, that's a UE. So all it is an end user node of some sort hanging off an LTE network. Okay? Because you'll start hearing marketplace the LTE named versions of things, and we all know how acronyms can really hose us up when we don't fully understand what they're saying. So on the subscriber side items, 1,000 times to 1, it's this guy in 365. The only difference in the 251 is this number changes here. Price is the same. Description is exactly the same, except it talks about slightly different frequency range. This subscriber is a little unusual for an LTE subscriber in that it covers 2 bands under LTE. Most LTE CPE, as I understand it, cover 1 band. And the same is true of the 2.5. The 2.5 covers what they call band 41 and band 42. This CPE has both voice and data. It comes with a PoE. It comes with iPerf. It comes with built-in SIP client. It comes with built-in surge. There's nothing extra. It comes with it, and I'll show you pictures. As needed, you might think of some of these alternative pieces. So this is that same thing above, but with dual end connectors. I think, unfortunately, I think it's cost somewhere about end number, probably about 50, 60 bucks more or something. More often than not, you'll not use this. I think probably 95 to 5. You know, there might be some rare cases for those of you who are really maybe pushing the envelope. You don't have the density, and you want to get some guys more outside the edge. Maybe you do this, and you put on a reflector, and you pull another 13 dB or whatever it is you can get out of it to get in there and keep the total capacity nice and clean. This is an option, which is a vertical wall mount. I'll show it. We have multi-packs, and then this is an option that replaces the PoE. I'm going to show you pictures of these again. And then there's a SIM card. That model has changed. You can see now there's a minimum order quantity of 500 units. What? Who's going to do that? You're not going to, but your supplier will. So my advice to the suppliers, to the vendors that are carrying us, is they order these, and then they preload into the CPE that you order. That's the way it should happen. Whether or not they take that advice is ultimately not up to me, but that would be my advice for what they do. Now these SIMs come kind of pre-programmed from the Telrad side. Nick, do you want to speak to that at all?
I can just comment that it's a very straightforward process. We provide essentially raw data known as an output file correlating that, which is the INSI, which is the mobile identity programmed on the SIM along with the authentication key, and then it can be exported or imported into an authentication database on a radius or leveraging our internal HSS functionality.
Okay, so whoever understood that. And again, we're happy to do one-on-ones following up on this stuff, on anything. So this is what the CP looks like. This is dual mode. Again, it's WiMAX and LTE. Why is it also WiMAX? Well, we have a lot of legacy customers that have WiMAX. So we're into providing backwards compatibilities and protecting the investment of our customers. It costs more to do that. It kind of makes R&D a little tougher, especially those guys trying to convert from the old big heavy iron IDU ODU model. But in any event, we needed a CPE that bridged that that transition from WiMAX to LTE. That's why this is dual mode. All day, every day, worst case basis, your number on this is about 275. And frankly, unless quantities get up into the thousands, there's not really quantity breaks because these things are manufactured in huge numbers by our contract manufacturer. So in order for us to influence the discount to the factory that contract builds this to us, has to be a pretty crazy number beyond the expectation that's already been baked in for whatever the quarterly agreement is, production agreement. But you can see there's a little grounding port. This right here is actually a window into a I believe it's a 5-color bar and all the lights. This also unscrews in the SIM card slots inside here, actually. It comes with the PoE. This is, by the way, is roughly about 10 inches square. So comes with the PoE. If you don't want the PoE and you want to do something different, you want to control the Wi-Fi in the end user's home, which a lot of people do so they can avoid calls. Right, Joe, if you're on there, people calling about their Linksys or Netgear or whatever it is. You can control this and you can manage this across the network. It's simply a 2.4 802.11n 2x2 MIMO AP that pushes out the PoE to this guy. Your number on this is, as an end operator, is probably a $50 addition to the CP cost, maybe $45, depending on who you're buying it from. I'd say between $45 and $50. So it's not really a bad deal if you lease that back to maybe to the subscriber, and then you control that part of your destiny as well, and you make your service more sticky. Okay, this guy, so I showed you some of the options under the Consider These title. Well, consider this. It comes with this pole mount right here. The CPE comes with that. You don't have to buy it extra. But if you want this vertical little mount, that's what this guy is, and that's what it looks like, right? This can actually go under the soffit. It can go in multiple different places. It's a pretty simple little mount. But that is one of the options that doesn't come with it. Also, the cable between the outdoor units and the PoE, we can provide it. We're probably more expensive than you can otherwise get it yourself, but we do use a very, very good high-end cable, and I've sent those specs to the list, I think, before with images and everything. So, now, I don't know if he's here. Let me look. Daniel, are you here? So one thing we were waiting for, I was waiting for pictures to be sent from Mr. Daniel Ungoy, or excuse me, Daniel Moore at Ungoy in Iowa. So he's into his 9th base station now, which is not bad considering he put up his first one just after his panic call to me in Thanksgiving. So Daniel, I just sent you an audio pin, so you could unmute if you want. But he was going to send a picture. I don't know if he had it. If he gets it to me late, then I'll send it to everyone. over email, but there's also photos of the subscriber and a Google Earth cut, but I understand it's about 4 miles in a hole, completely obscured by trees, as in his term, trees galore, and getting 30 megs. So he's on, there we go. Daniel, are you there?
Yes, I am. It should be in your email.
Oh, it is? Okay, so I'll try to pull that up. So guys, this is a little dangerous for me. I haven't seen these. Okay, so this is from the subscriber back to a tower?
Yeah, that's actually his driveway. His house is behind those trees there.
The house is behind here?
Yep.
Okay. And also I should note the CP, as I understand it, is not really optimized on the location, right? It's just kind of there.
It's about 5 feet off the ground.
About 5 feet off the ground? Okay, so, okay. So certainly not a location that, yeah, that's cool. Okay, so that's at 5 feet. Good chance you're probably not connecting that with a lot of the stuff you guys might otherwise use. That's at 4 miles, and you're getting, you said, about 30 minutes.
That's the line of sight past those trees at his house. So there's another tree line right past those tree line at his house.
So there was the first tree line, and then this is the second tree line?
Yep, on top of a hill.
On top of a hill. Oh, okay, very cool. Dude, thank you. So, all right, so we're just kind of skimming across the treetops, so to speak, except for the edge here where we're clearly going through some stuff. Okay, so, and this is, Daniel is in beta, and as I said just in the beginning of the call, when you agree to do the beta, you agree to take a little bit of pain because there's a lot of work. He's been terrific in helping us with this. But this just went up last night, actually. So you're frankly the first in the world to see these, and you're seeing these with me. And even our own guys are a little squeamish about showing this because things are not fully baked as you would expect with the beta. There's guts along with the glory. But this is a really good first step, and we're driving towards the commercial release, which, again, we fully expect to happen inside of February. And it's things like this that's going to help us get there.
I should note, Patrick, this customer is actually on the very edge of this beam, so he's not anywhere ideal conditions whatsoever.
All right. Okay, so you can see it is in the 365. So you're only operating off a, okay, this is a center frequency, so this is a 20 megahertz channel, or 10?
Yep, 20 megahertz.
Okay. All right, that's outstanding. I don't know if any questions are popping up there, Nick. Maybe you can see. But Daniel, I really appreciate you sharing this stuff. I'm going to, I'll capture some of this stuff and I'll put it inside this little presentation. So when I send this back out, I will have that in there. Was that really a -114 RSSL? How is the latency? Okay, so you are getting some questions.
I can answer that. RSRP, it's an LTE term. It's basically a received signal at the subcarrier level. So you have to consider that the power is relevant to a 15 kilohertz tone. If you wanted to compare that to say what you're used to on a 10 megs channel with WiMAX or with Cambium, you'd have to subtract 30.
Okay, so we're really looking at 84 from an RSSI standpoint.
Correct.
Okay. All right. So I hope that answers your question. Now the latency question, did anyone want to speak to that?
We should expect somewhere around 30 millisecond, 32 to 35 over the into the core. We have to consider that this is reaching his core and then surpassing the internet. So that that would be fair.
So from the core to our tower, and I should say from the tower to the internet, we see about 35 milliseconds.
Okay, perfect. So we're well within the low latency levels that we're committing to.
All right. So Corey had a question about coexistence with another operator. Nick and I are planning on developing a pretty comprehensive bit of material to kind of address this, since people do talk about this frequently. Nick, you can hit that briefly now, if you like, in terms of interference mitigation techniques relative to, whether it's wine or just the approaches we take.
Sure. LTE in general and how we are targeting our system is things such as frequency selective scheduling. So, for example, the subscriber unit is consistently providing a channel state indicator, a channel state report, to the base station or to the eNode B based on downlink signal to noise and interference conditions. With that information, the scheduler is adapting the modulation and the coding, of course, but it's also identifying subcarrier level less optimal subcarriers for potential partial overlap within the band, and then scheduling the subscriber unit around that interference, not necessarily trying to push data through the worst quality subcarriers, but identifying the better quality subcarriers and scheduling that data with those resources. So that's frequency selective scheduling is just one example, in addition, of course, to enhanced intercell interference coordination and the ability to coordinate within an operator network, specifically cell edge allocations, to ensure that cell edge area is not allocated resources to overlap with an adjacent tower within your own infrastructure. So those are two mechanisms, one for third-party interference and one for self-interference, that really do serve to mitigate that interference.
Yeah, you also have the just the simple fact of dual carrier. With dual carrier, you literally have frequency redundancy. So, you can use it both to increase capacity or to give you additional resilience. So Ubiquiti has a special name for that they use in their new backhaul piece, right? I forget what they call it. But basically they have two radios in there and they load balance between the two carriers like ours does in multipoint. And they talk about that having, interference resistance, powers. And I guess it had me thinking in that way too, so that's certainly true as well. So, again, thank you very much for that, Daniel. I know you've been incredibly busy because this has been really crappy weather from the moment you put up your first base station. So it's remarkable that you're now at your ninth. So it's pretty exciting stuff, and we really look forward to see how your stuff progresses, as well as some of the other guys. And there's a couple other guys that are just now getting this up in beta as well. So now we'll move to the LTE core part and the NMS, because this is where it really gets kind of confusing. So remember, we were looking at this. So you've got your radio access side, you've got the tel core, the enhanced packet core, in LTE speak, the EPC, and then you've got the AAA on the back office side. So let's look at the NMS first. Now there are going to be, like I understand it, some slight changes to this. Our NMS is moving from an SNMP and Java-based thing to a netcomp base, which is a nice, lighter, more modern way of doing this. I understand Nick says that Juniper has moved to netcomp and some others, and that it's just a better approach. Nick, I'm not sure if we're still going to have 3 modules entirely, but this is the way it is now. I've got these colorized in ugly colors here for a reason. So the NMS has nothing to do with the billing side. It has nothing to do with the authentication side. It has nothing to do with anything on the opposite, going from the radio access network side to the internet or to the back end. It specifically deals with the radio access side and your visibility into it. Now, we have 3 pieces that together comprise the suite that we call Star Suite. And for better or for worse, I'm not saying this is the perfect way to do it. I'd argue quite the opposite. but this is how it is. So for my guys trying to understand the pieces and parts as they exist today at this moment, this is how it works. TV white space, not yet. And I'm not sure if it's on the roadmap. It's one of those things we talk about from time to time. But this is our, our space is right here, 365, 3.5, and 2.5, and then 2.3. But maybe in the future, it's an open question. Anyway, back to the NMS. There's three pieces. There's Star Manager, which all you really need to know is it's the bulk module, the module for bulk management of base stations, configuration, provisioning, and it covers this part of the radio access network, just the base station, the stuff on the towers, the E-node-Ds in LTE speak. Then you have Star ACS. So ACS is commonly used for large-scale networks for management of the subscriber side, right? It's a lighter way to get into the CPE and get information out of it versus, SNMP or something, because it uses much less resources. And this uses TR69 and only deals with provisioning and mass bulk management of the UE or CPE. So you either got this piece and this piece, or you just got this piece. Whichever set of these two you have, if you also have this, then that covers the performance, the KPIs, trending, all that sort of stuff, historical from day one through the operational time of your network, exporting all the metrics and from Excel and everything. That's Star Quality. And Star Quality covers the entire range of your radio access network, assuming that you have these other pieces. If you only have this piece, then when you have Star Quality, you only are getting that super comprehensive, granular visibility into the base station side. And this you would have to go into one by one if you didn't have Star ACS. So ideally, once you get beyond a certain point, you definitely, as Joe also told me yesterday, if you're scaling, it's close to useless unless you have full visibility. And I'd probably argue that's true, because you don't want to scale without the full visibility. We can go into it and show you what you get under this sort of thing. Nick, if you want to, if you got a live sector you want to pull up, I'm happy to let you do that. And you can show people kind of quickly some of the default views that you get in Star Quality. Many of you have not seen it, but it's covering not just the data performance, but it's also covering in detail the RF values that the network is seeing on a network level, on a regional level, on a tower level, on a base station level, or on a subscriber level. Did you have the ability to look into that, Nick? Are you there where you can get into one?
I'll have.
Say again?
I'm just connecting a VPN, so if you want to continue, that's fine. I'll have it pulled up shortly.
Okay, yeah, just tell me when you do. I would like to place a Wi-Fi router behind each CPE and use PPE for authentication. Care to multitask and answer that while I move to the next slide, Nick?
Okay, I caught the PPPoE as an authentication component. The thing here is that we're dealing in LTE and we have an advanced scheduler over the air. So we want to provision subscribers on our EPC to take advantage of advanced QoS and scheduling tactics that are available within the ecosystem. Also, the subscriber units by standard need to authenticate against a SIM card with an IMSI. That's just the standard component, and there's really nothing we can do to get around that without defining the standard. And we've already run into some products that do kind of hack up the standard, and it just becomes a nightmare for interoperability. So with that in mind, we do have an integrated HSS, which allows you to provision subscribers and have them authenticate to a subscriber list or database built into our EPC. So there's no need for an external component to perform that authentication.
Okay, so again, the summary of the Star Suite is you got Star Manager, you've got Star ACS, and then you have the Star Quality that kind of plugs into both of them together. That gives you all the metrics. Again, I can go into detail in this stuff, and we do on the most of the webinars. This is just trying to get you to at least understand the pieces and parts, not necessarily a specific functionality, although Nick will jump in. Now, okay, what do those parts look like in an Excel file and a bill of materials? So from an ordering standpoint, here are some of the items under the NMS in a typical bill of materials. The line item that most people see to start, and the only one that most people see when they're just starting, is this guy right here. So this is what we call the Star Manager Startup Kit. Okay, it says Star Manager, meaning that is just the Star Manager component for base station configuration, provisioning, and that sort of thing. This serves up to 15 compacts, so once you have this license, it's good for up to 15. It includes the server license, some clients for whether if you have a tech remote or whatever. As you scale, you might want to consider this part number, which upgrades to what's called the full kit, right? If you're super scaling, there's all kinds of other stuff that you can do. Most of us will never see some of this stuff because it's over, 10,000 subscribers, and believe it or not, they do exist. We've got a guy up north who's approaching 100,000 subscribers in over 2,000 sectors. It happens. By the way, we're not their only vendor, right? They have a dual vendor approach, as often people that large do. So if you're a larger guy and you're starting in scale and you're not starting in trial, and there are a couple of you in this boat on this call, this is the part number for the full-blown NMS, all-in-one, everything included in the alphabet soup of the management system. This includes Star Quality, includes Star NMS, includes everything you need up to 30 compact base stations. And then beyond this, there's just a small individual per base station that you can add. So this is kind of the soup to nuts. It is kind of a big nut, but if you're a larger network, and by larger I say it starts to make sense probably maybe around your fourth or so tower perhaps. And then once you've done that, it amortizes out pretty favorably in terms of the cost spread out across the infrastructure. Okay, Nick, since you've got that ready, I'm going to pop on over here.
Sure.
Okay.
Okay, so just to confirm, do you see?
He's dialed in. He's logged into an existing operator. So take it from here.
Sure, thanks. So you can see the Star Quality view, can you?
Yes.
Okay, great. So basically, this is the Star Quality component, which is the historical reporting key performance indicator trending tool or module within our NMS. There is a long list of key performance indicators and counters that are being constantly pulled from the base station, both at the base station level and the subscriber level, that are being trended in this table here. You can define threshold alarms, notifications based on alarms, or just built-in canned reporting for daily or weekly distribution based on network performance. In the case here, this is a 10 megahertz channel actually in a WiMAX format that I'm demonstrating right now. And note this, this sector has over 100 subscribers. And just to show you just how granular we can get with these key performance indicators, this is what's known as airlink utilization. If you focus on the red line, it's actually the downlink data zone component of the airframe. And you can see here at peak times daily how it's getting close to maxing. But we're still servicing 100 subscribers plus on this sector with really no starvation for resources. So that's really the key thing to emphasize here. And oversubscribed, we have around 500 megs sold on that sector, just to give you an idea of how oversubscribed it is and how much utilization translates to that oversubscription. So you can immediately and dynamically identify your oversubscription on a per sector level based on the user's consumption within that demographic, within that geographical area. It might not always be the same brush. There could be some more remote areas, perhaps with elderly people that aren't necessarily downloading and running Netflix, and you could even push your oversubscription further. But the key here is having the tools to identify your limits and your thresholds that you can work.
And by the way, one of the reasons that this particular operator can, they can really push their oversubscription. By the way, their average package is about a 7-1. That's about average on a sector in terms of 7 down, 1 up. But one of the reasons they can get really aggressive, and there is a sector here that in this network that's got 185 users on 1 10 megahertz channel, is because the worst thing that can happen is they can, via software switch, turn on the second carrier, and then the traffic will automatically load balance between the two. So you can really, really get aggressive in maximizing your investment because you've got that backup in reserve that you don't have to pay for until you need it, which is kind of nice. So it's only there, really when your capacity requirements demand it, but it really does let you push the envelope comfortably without worrying about it, right? Because if you're really testing it, and some of these sectors for this guy are really coming up to the edge, you're still good to go because fire up the second carrier and boom, just add water. You've doubled your capacity and you're balancing the traffic. These are the default views, by the way, he's showing. You can create custom views, but there's about 30 that come to you by default.
Exactly, and something to highlight and identify here is that we can actually see the percentage of MIMO A versus MIMO B trended. And it's about a 75-25, even more so in favor of MIMO B, even up to 80-90%. This, of course, is what you want to see when you're looking at things like spectral efficiency capabilities and ensuring that you are operating in the most optimal means of spectral efficiency and modulation and coding. Here we have retransmission, so HARQ counters, uplink and downlink, some overhead components. Right here we're looking at modulation and coding broke down in basically a data per MCS type or modulation encoding type. This can be exported to Excel, or you can just pull all the raw data out in a full table known as the bulk export wizard. So you can see all the.
This is a big deal, right? Because I've heard some people say, oh, how do you get RF statistics, for God's sakes? Well, you can see here because this is breaking down literally the percentage of subscribers in every modulation available on the radio, how they're operating, so you really get a sense of the efficiency of this particular sector as a whole. It's pretty cool, granular stuff.
Uplink noise as well. You can see that the list goes on. Signal to noise and interference distribution is right here. Again, a great KPI because you can see around 60, 70% of the subscribers are 21 dB CINR or better. And then, as you can see, it's all here in the raw data format. You can see 67% at 21 dB or better. Then there's a small percentage in between, and it continues on. Here's also a key performance indicator that is very relevant. Spectral efficiency. Of course, it's relevant to data. If there's no data in the buffer or being transferred, then there's nothing to measure. But note that this is under the assumption of 64 QAM 5.6 MIMO B. So that really translates to 10 bits per tone. 10 bits per tone, rather, spectral efficiency would be the peak in the technology as it is today, or in the WiMAX or in the initial LTE release. But as we move into MU MIMO or 4-layer MIMO, in combination with 256 QAM, that 10 is going to increase to 28. So the spectral efficiency, you can see all within a year. It's all planned within our roadmap within the next 12 months to push that much, much further with regards to further capacity increases. So this is base station level KPIs, but just to touch on the fact that we still have this visibility at the subscriber level. And just like I drilled into the specific base station for the base station level KPIs, and I'll also note that these trended charts are available on our core, on our EPC as well. Here I can just randomly pick a MAC address and just correlate it to the drill down table and see this end user's conditions, retransmissions, further to that, their downlink receive signal around the mid-neg 60s, and then there's a min-max within that period. Of course, one single sample measured at a lower power will contribute to the min, and vice versa for the max. But you look at the median, you can see that that CPE trended over a period of time. Signal to noise and interference trended as well. The spectral efficiency for that specific subscriber, and here's their throughput. So in order to drill into a specific time frame for throughput, you can actually do that just by dragging your mouse and zooming into a very specific time frame where we see this user did 3.5 meg, at which time it was 99% MIMO-B. So you can see how inactivity can contribute to skewed results, but here we know that the subscriber is doing 6 bits per tone when actually moving data at 99% spectral, or rather 99% MIMO-B. So just a means of drilling down. That's the key, being able to have that visibility at the network level from the UE or from the CPE to the base station to the core.
So Nick, thank you very much. I'm going to jump back to the bill of materials part. If I can find myself here, there it is. And then if you want, if you have it, that one where you showed that Google Earth file of that 16 km link is always pretty fun. I don't know if you're available to do that, but if you can, just let me know and ping me. So again, that was the NMS part, and Nick just showed you kind of just a little bit of what you can do for the KPIs on the star quality side. Okay, I see that. Got it. Now, if you look at the core side, this is where Nick is probably going to have to chime in a lot. So we said the EPC, the NMS side, only deals with the RAN, radio access network side, going this way. So the EPC, the core, AAA, everything else is on the opposite side of the network, and as the arrow denotes. Well, we make this piece of it, and we call that the Tel core, which is Telrad's Enhanced Packet Core, or EPC. We do that in one of two ways. We have the ability to embed that via software, so it's a hardware-less EPC, and we can do it, it's on a per base station level. So obviously that means a distributed way of doing it. Or we have standalone 1U stackable EPCs that you can literally add HOTS and cascade, and as you do that, they will load balance across the stackable units. You're only doing that really when you're super scaling. The EPC does a couple very, very important bits of functionality, most of them having to relate to the mobile world. But it's part of the standard, and there are pieces in there that are relevant to us. So the things that the EPC does is it has this functionality. I have definitions in the back of this presentation. It does the FGW, the PGW, the MME, and it has the policy controls and rules function and the home subscriber service function. We have actually broken these, we're actually breaking these two pieces out individually and going to offer them in a modular way, and so people don't have to swallow the whole pill. And we'll explain that to some degree. But this is where it gets a little, for people to understand the piece. And this is the part that does interface with the external billing component and that sort of thing. So having said that, let me show you here. So the actual part number, what it looks like, an embedded EPC license is simply the software key that goes inside an individual base station that supports the EPC functionality for up to 50 subscribers. And I'm not doing a qualitative thing over why things are. I'm just trying to explain this is how it exists today in the pieces and parts. So if you see them on a bill of materials from your vendor, you'll be able to more understand this. And again, I will provide this material to you. As you scale, you would either, there's a couple things that you could do. You could add additionally of these guys, and this is not a big number, or in fact your number is probably closer to about maybe somewhere in 1,200 or something like that per 50 subscribers. I think that's roughly correct, if that hasn't changed. If you're scaling and you're getting bigger and bigger, you might want to consider moving to this standalone version, which looks just like this, and that's what it looks like when it stacks. Because this guy gives you, it includes a license for 1,000 subscribers. It supports up to 10,000 subscribers. In other words, you can plug additional licenses in to get up to that number before you're really forced to do another one. You can stack these in a cluster. Each one will support about 2 gigs in throughput. So in the EPC, and oh, by the way, we're the only ones we know of offering an embedded EPC at all. Cisco's version of this, of an EPC, is deep into the 6 figures. Some of these things, I think Matt's on here, he can tell you the Ericsson EPC is a full rack worth of stuff, and I think you're approaching $500,000 or well higher. We're not talking about stuff like that. We're talking about, you know, more like in this case, $1,100, $1,200, $1,300 or something like that, right? And if you're super scaling, here's a part number, for example, that would allow you to do EPC and additional hunks of 500, excuse me. And there's actually one of these for if you're buying 1 to 20. There's one of these if you're going from 29 to 50, and one of them from 51 to 100. Whatever. I don't expect to be selling any of those, or hardly any of them. So just on the summary of this part, and we've got some other stuff that we can show, that I'm about to show, in terms of what it looks like on paper, one full bill of materials for all the parts, and what that gets you in terms of capacity, subscribers, and stuff like that. So there's a lot to digest. You know, when you're uncertain, call us. Let us know. We'll walk you through it as much as possible. We're doing all we can to try to optimize this for the WISP space. You know, this is new to almost all of us. It certainly was new to me. I've asked a lot of what I call dumb questions, certainly to Nick. He's been very patient. Don't let yourself get frustrated. And if you're building this thing, accept the help, because the typical process, if we're not there on site in person, is to remote in and bring this live up remotely, as Nick has done with Daniel. Whenever you can, if a session happens like that, my encouragement is to record that session if possible for its training value. But in any event, ask, ask, ask. You know, if you're getting frustrated, it means you've already gone beyond the point where you probably should have called and asked. And you know, we all are learning new things constantly. So. Now that said, I wanted to show you guys what a bill of materials looks like for a typical 365. Because if I showed you the full BOM, this is all the pieces and parts just on the base station side. Obviously, not relevant for everything. This is all the stuff on the CPE side. Lots of different options. NMS, it's just as crazy. Right? There's all kinds of different pieces and parts. What most of you would ever see would be this complete set. Okay, so you would see in the base station elements, you would see it looking like this if you chose this mounting option. This, by the way, these together form, I think, somewhere about a $300 or $350 additional dollars. It just makes for a nice, elegant mounting, but you don't have to do that. That's optional. So this is not optional, obviously, and the GPS is required. This, for LTE, is required. And then, again, as you scale, or things you might want to consider, for example, if you're over there in Phoenix, like I know one of you are, should we be planning for AV deployment or ABC deployment on the sectors? Chuck, depends on what you're doing, where you're going. I think Nick would tell you probably most people in here will be doing ABC, and some maybe even less than that. Nick, you want to comment?
Certainly in areas where there's density, I like the AB configuration, 4-sector, even sector distribution. It's in 365. It's really efficient use of the spectrum, and we have great results in widespread kind of deployments with that method.
So Brian, you asked about the second carrier. What does that mean? Let's do this. This is what I mean. So basically the base station, it's got 4 transmits, 4 receives, right? There's multiple radios inside this thing. It comes default, it ships with 1 carrier or one, as you can think of it, 120 megahertz in LTE channel stock, right? You can deploy that in 4x4. That's the optimum way to deploy it off 1 antenna. So you get 4x MIMO out of that 1 channel, supporting, you know, whatever geography you're aiming that thing to. If you want to fire up the second carrier, that basically turns on the second 20 megahertz channel. By the way, there are other channel sizes, but let's just talk about the max LTE channel size. It turns on the second 20 megahertz channel size. Now you can deploy that in multiple ways. The most common and most likely way is this way, where you're doing it out of that same antenna that you already got hooked up, so there's no additional climbing, there's nothing you have to do, you're just turning it on. And what happens is you now, instead of have 1 20 megahertz channel going out that antenna, you have 2 20 megahertz channels pushing out that antenna on 2 sets of frequencies, providing in the first load of LTE about 200 megabits pushed out that antenna, and the traffic load balancing across those sectors. Now, if you're super rural and you're in the cornfields, or you're in a place where you don't have, you don't need the 4x4, which is giving you the really good non-line of sight performance because it's 6 dB improvement on the uplink, among other things, you can do this with dual carrier. You can take that 1 base station and you can go 2x2 in one area, 2x2 in another area. Actually working with a transportation organization which is looking at this because it can aim down the tracks one way and then go the other way. Or if you're on the edge of, you know, you're in a community that's small, you are in some desert area where the line of sight issues aren't significant, or you're in Bend, Oregon, you can do, you know, you can do this. If you don't have the demographics to get everyone to maximize your capacity in a configuration like this, maybe you go here. It's just an option. So that's a long way of answering your question, Brian. So those are the base station. Can you clarify part number? It says LTE license 10 or 20. Which one is that? Let's go down here. Okay. All that means...
Patrick, it's in the main section.
Oh, again?
I was just saying that 715773 states 10 or 20, and really that just means that you can use either bandwidth. There's no limitation. It's not specific to a bandwidth. When you purchase the LTE license, it's just wide open.
Okay, there you go. Hope that answers you, Garth. So again, those are the base station pieces that you could and would have. By the way, if you're doing the attached antenna, you don't really need this because obviously the antenna is providing the sun shielding. If you're doing this, you know, if you are doing SFP, which I've got guys in certain parts of the Midwest and also especially in Florida that like to use the SFP because of the lightning risks that exist there, you know, you might want this. Notice I say consider. Doesn't mean you have to necessarily unless you're going this route. As you scale, which means you don't have to start, and most people don't, but as you do scale, and if you've got the demographics to support the capacity, you would order this, and this is a software key that fires up that second 20 megahertz channel. Now, in the first version of LTE, what that means is that's giving you another 100 megabits of capacity out of that base station. About 15 or so, 12, 15 or so months later, that's actually giving you an additional 200 megabits of capacity out that sector. What is this number? What does that mean from a CapEx impact? Okay, this number is, I think, to the end, to a WISP, is probably a software key that is likely maybe in the $3,300, $3,400 area, something like that. But there's no tower climb, and it's just add water and a lot of power and, or excuse me, a lot of additional capacity. And then there's this part number that you might want if, you know, just to have some spare little bits and bobs lying around. And again, there's the NMS. And this is what you'll likely see. By the way, in trials, we have trial licenses for anyone that is trialing. No charge trials for, you know, generally, you know, 30 days, but we also, in certain cases, can do 60 or whatever. Any of the NMSs we can do by trial license. And the same again for the EPC. So this is all in one list. Now, what does this look like in terms of when you start adding quantities? Let's look at it like this. Typical with quantity. Okay. So you'll see that this column is one sector. So these are the minimum items you need, except for these two optional items. The minimum items you need for one sector. So everyone's asking me, okay, what's on the bill of materials? What do I need just to do one sector? Or what do I need to do one tower or 3 towers? Obviously, base stations, you can see the counts, the quantities. Antennas, 1 for 1. If you're doing the compact attached mounting kit, 1 for 1. Same with the GPS bracket and the GPS, notice that's a 1 to 3. Obviously, you need the first one. So what this is telling you is the cost per sector starts to drop a little bit per tower because you've already got this piece. You don't need that until you go into another tower. The same is true as you come to the NMS. Now, again, we can do this all by trial, but if you decided to go active and go live and activate that, this is the one guy, the one part number you need. But this is good for up to 15 compacts. So you don't need any more of them as you go to a full tower or to a couple more towers, or even until you're done with 5 3-sector towers. It's still one. And then it kind of scales like this on the embedded EPC. That's most likely how you would do it if you're starting out small. And this is a 1-to-1 per base station. And then if you get more than 50 subscribers on one base station, then you would have an additional one there. Now, I don't have subscribers on here because we all know how subscribers look on a bill of materials. It's just kind of 1-to-1. Now, what I want you to understand also is that as you're looking at this stuff, what does one sector get you? One sector with the first carrier active, which is how it comes out of the box in LTE version 8.9, which is how it starts, is 100 megs. What does that give you? In the first carrier at 25 megabit service, all day long, you should be able to get, in one sector, 30, 25 meg subscribers. Why do I say that? So if you've got 100 megs, let's figure only 75% of that is available and the top modulation, and we have some of those graphs Nick showed you. You'd see 85, 90% higher, or certainly 75 and better in the top mod. So that's very realistic number. So let's say 75% of that capacity. And then let's do an oversubscription of 1 to 10, which for us is very realistic. We think 1 to 15, even in a network world, is realistic. We have people going higher, but let's just be super conservative. So 75% availability and 1 to 10. So you would take that 75 megabits, multiply it times 10. There's 750. If you're doing 25 meg service, divide that into the 750, and you get 30 subscribers. Now, if you were to fire up this second carrier, the second channel, that sector is now pushing out 200 megabits, or translating into the ability to connect 60 25 meg customers. Okay? So at one tower, this is what that looks like. One carrier, 90, two carriers, 180 at this subscriber level. At a 10 megabits average, instead of this being 30, that number becomes 75. This number becomes 150 at 10 megabit average. This number becomes 450 at a 10 megabit average on a full tower. Now, in about 15 months, when multi-user MIMO, 4-layer MIMO, 256 QAM gets added on the roadmap, because this is what's coming. Sorry, here, right now. That's just kind of an all-in-one presentation. Because this is coming in version 7.0 and 7.5. Because that is coming, that will double the capabilities of the sector, right? So if you're there, then with one carrier, you're looking at 60 25 meg customers. With two carriers, 120 25 meg customers. Now do the math. So on one tower, that same base station now that is, only delivering maybe this doubles literally overnight with the software load to this. By the way, that software will not cost you anything, provided you have an SLA, which we only apply on the base station and licenses and NMS, and it's just a fraction of that. If you're on the SLA, that stuff comes and you just get it. So, but that doubles capacity. So I think when you're talking about this, you're really talking about truly the ability to compete head-to-head, with cable operators, the kinds of speeds they can do, or pretty darn close to them, in some cases better than them, depending on where you are. So now, if any of you would like to understand that roadmap a little bit better, I'm going to encourage Nick to go through some of these, because I'm guessing most of you probably don't fully understand this. This is not 4x4 MIMO. This is 4-layer MIMO. Nick, if you could speak to the difference and focus on these guys, these ones here, and then the significance of these guys.
Sure. Sure. So previously when I demonstrated the spectral efficiency KPI, I referred to WiMAX being 2-layer MIMO. So in the case of 64 QAM 5.6, that's in MIMO B 10 bits per tone spectral efficiency. So that's because of the space-time multiplexing over 2 layers of MIMO. As we move into 4-layer MIMO, we're actually introducing an additional 2 layers. So meaning, of course, space-time multiplexing by means of 4 unique data streams. So taking that once was 2 times spectral efficiency and turning it into 4 times spectral efficiency. Now, 4-layer MIMO comes with some limitations of, for example, higher requirements for signal-to-noise and interference conditions at the subscriber level. But the best and most optimal workaround or solution to that is multi-user MIMO. What multi-user MIMO does is takes the same 4 layers but services 2 unique subscribers, each with 2 layers. So again, doubling spectral efficiency, but in a different way that is more flexible on the subscriber level signal-to-noise and interference requirements. So both these techniques can take a sector capable of 100 megabits on a 20 megahertz channel and turn it into a sector capable of 200 megabits on a 20 megahertz channel. In combination with the next feature, carrier aggregation, which takes 2 20 megahertz carriers and can bond them at the component level, at the layer 2 level, so that it's transparent at the higher layers, so the end user, a capable CPE, is seeing that as a 40 megahertz channel and can exploit peak rates equal to the sum of the total bandwidth, i.e. 40 megahertz. And further to that, there's the 256 QAM, which of course is just a higher form of modulation and encoding, spectral efficiency, of course. On the interference mitigation side, I had mentioned previously the frequency selective scheduling. So basically an adaptive base station that's not only adapting the rate to the specific subscriber, but it's adapting the subcarrier allocations to be the most optimal for that specific subscriber. So that is the mechanism that is putting the intelligence into the base station to identify interference and schedule subscribers on resources identified as the cleanest interference, signal-to-noise interference-wise. And further to that, there's the enhanced intercell interference coordination. So it's really a combination of three techniques of dynamic frequency allocations down to 1/6. For example, in a reuse one or a network leveraging all one frequency, adjacent sectors will have areas of overlap known as the cell edge. Having a user being identified by the base station as being in the cell edge and then coordinating with adjacent sector over the IP interface, not over the air, but over an IP interface, down to a dynamic 1/6 of bandwidth allocations to ensure there is no overlap in the resource block allocations at the cell edge. That is also using power to adapt and ABS, the almost blank subframe, so half a millisecond duration, when one base station can relinquish the airframe to provide full control or full resource allocations to an adjacent sector and adjacent cell. So it's always happening in the background and always negotiating. And just further to that, on the core side, we have this self-organizing optimizing network. This is it's a wide umbrella, of course, of feature sets specific to self-healing capabilities. So a network that's always listening and identifying failures and for example, enabling a second carrier or making a recommendation for a change at the core level to adapt to some type of a network event, perhaps a backhaul failure where it can increase the power and capacity on an adjacent cell to try and compensate and pick up as many subscribers as possible from the failed base station, just as an example. In addition to that, there's self-optimization, which again is listening for interference and making recommendations to the operator or the network operations center for changes that can further improve the capacity and the optimization of the network. And the last one here, it's a new one that we're working on, and it's certainly a great feature for our VARs and our channels and our dealer network, of course, is this cloud NMS. So having one centralized NMS that is managed by, say, one of our partners, but servicing 5, 6, 7, maybe 10 smaller wireless internet service providers. The individual end users or internet service providers can only see base stations partitioned to their segment of the network management system, but the administrator or the VAR or the channel partner has control to administer as a whole. So it's really essentially partitioning the NMS into a cloud solution provided by a third party as a service.
So, Alex, you had asked about the SAS, especially relevant to 3.5. So that's a good segue, right? So the ability to do these things as a service is definitely part of it, and this is one of the powers of being a software-defined radio, right? So we can embed the SAS functionality right there in the base station, and that's ultimately the intent, right? Whereas a lot of people will have to have an appliance sitting between their base station and you know, whatever the SAS thing is to get out to Google or whoever is going to be managing that dynamic database. We expect for us it's just going to be a software load in terms of you know, getting that functionality into our box. This base station, this eNode B has got a lot of spare FPGA space on there. So that's one of the magics of this guide. In fact, as Nathan at Whisper, you know, told us, you know, one of the things that made the numbers work for him was that this literally changed, and I mean literally, the formula for how he computes CapEx, which was previously based on a much shorter time span. In this case, it's 7 years and out before an anticipated hardware change for them or for us at the tower, which is really unheard of in this business, right? How many of us have stuck with the same base stations? Now, maybe we have, but probably what we've witnessed over that time frame is our ability to compete with the new stuff being compromised. Well, what we're telling you is one hardware platform going out that long and during the entire life cycle still allows you to compete, which is a pretty impressive thing. It's never been done in these common frequencies before, ever. And so having that capability, I think, is one of the things that really does kind of change this game. That and the non-line of sight thing. I wanted, before I closed, we are, actually a little bit past our time, and keep the questions coming in because we're paying attention to them. But I wanted to address a non-line of sight because for those that haven't engaged in the one-on-one presentations and stuff like that, excuse me, there's still some misunderstanding or lack of understanding of what's actually happening, and why we're getting shots like this in 365 where other people in the drive test can't get in their gear through this little wall of pines when we drive through. The reason being, I don't think most people really have a line of sight problem. I frankly think you have equipment problems, and as good as some of that equipment is, and as amazing as some of it has been in terms of reducing or eliminating the barriers to entry into the market, and there's no question that's what that stuff has done. There are some limits with respect to the specifications. So what happens that we're getting such better non-line of sight? Well, just this kind of breaks it down to a certain degree. There's no voodoo, there's no magic, it's simple numbers. In 4x4, you're getting 6 dB advantage in the uplink. So there's 6 right there. We all know what 6 dB does. On the power side, if you're only pushing out 22 dBm and then you're combining in 2x MIMO, so you're doubling ports, so you've got 25 dBm coming out of the box. In order to get to the FCC maximum in a 20 megahertz channel, you need to pump out in EIRP up to 43 dB to hit max FCC allowable power in a 20 megahertz channel in 365. If you're pushing out 25, you need a pretty big darn antenna to maximize just to get you to full FCC power. And then you've got to account for connectors and stuff. So you have some limited flexibility. I don't know if any 180-degree sector or 120-degree sector or even 90-degree for that matter that's going to get you 18 to 19 dBi. Well, we are pushing out 30 dBm per port. Power is expensive. It's one of the reasons these are expensive base stations if you only look at them on apples to apples. Power is very expensive. PAs. So this guy is pushing out 30 dBm per port. What does that mean? Well, in 4 ports in 4x4 MIMO, that's 36 dBm being pushed out of the box. So you have a lot of flexibility to get to 43, the FCC maximum in a 20 megahertz channel. You have a lot of antenna flexibility to work with, and most likely will be in a situation where you have to turn down the power. The second is just looking at the same modulation, the same coding, at the same channel size, right off the various data sheets, we've got an 8 dB advantage there. So if you take that 8, you combine it with the 6, and you talk about the power, without even talking about some of these other things, you've got 14 dB right there. And we all know what 14 dB means in terms of a link budget. It's the difference between not getting a signal at all and getting a stable link. So, okay, that's it. It's not magic. So that's just the last point I kind of wanted to make. I really appreciate everyone's time here. I'll try to get this up onto YouTube